You tell me when you're recording.
I am.
Okay, so this is the 7 pieces, 4 of the Peterson you sent and 3 of the Lapua. We're gonna expand them with our 317 expander. Let's move this expander down a little bit more. Okay. So you can see we've expanded it all the way down. So what this is doing is expanding it much larger than what the die neck diameter is, so that it can squeeze it back down more concentric to the axis of the body. Okay, now take that out, put our 30 BR die. It has a 330 neck. Oops. I'm gonna grab a measuring device to measure the OD of this neck. Alright, so that's 330 on the die. Let's throw this mic. Hold it in frame here. $338, which kind of lines up, right? Okay, so we're just gonna take this. I'm not really worried about bump back or anything for this test. Gonna spray some lube on here. Everything's reduce the friction. Come up, you can feel it, right? It's starting to, you can see it, size that neck, right? So the thing about this die is it's made smaller than what a full-length sizing die traditionally would be for new brass, so that it maintains that tightness here and tightness here to guarantee that concentricity. So you can see us pushing that back. So you can see we've hit on here and on here, okay? So let's see what we got here. So you can see on the Peterson, the body is not as big a diameter as the Lapua. And when we built these dies, and these reamers for these dies, we based it around Lapua brass. So those are the Peterson, here's the Lapua. See how the Lapua has been sized on the body much more than the Peterson? That tells you the forceness of the concentricity of the Lapua is going to be better than that of Peterson. So let's walk over here now and let's go take a look. All right, so we're going to see what we have here. So you can see we've got 1.5 thou there, got 1.5 there, basically. I guess a 0 for you guys. I guess let's go to 0 on the bottom end of it, right? So each line is a 1/2 thou. That's 1.5, right? So that means I measured the wall thickness of the brass. It's at 11.2. So we've got 1.5 thou. So that means to get cleanup 100% on this brass, if we go to 9.7, it will 100% clean up, right? It's thicker in more spots. It's like 11.2 to 11.4. So it will probably get majority of the cleanup done right at 10 thou end thickness. All right, so hold on here. Look at this piece here. Now that is truly less than 1 thou. Let's check in another spot. Less than 1 thou. Check another spot. Less than 1 thou. You've seen that these were all 2.5 to 3.5 when we started. Okay, that's those two. Let's check this third Lapua. Let's see if we can get that zeroed out. So that's 1/1000, 1.5. Okay, let's go back here. 1/1000. Okay, let's go over here on the end. You can see how it's projected, right? So now it's still a little over 1.5, because that's 1/1000, that's 1.5. So in my opinion, at 10/1000 even, that brass will 100% clean up, and we will end up showing that. This Peterson, I'm not positive of, because it didn't contact the body as much. But I've never actually sized Peterson in this die, but let's check it out together. So you can see there, that's 1.5, a little less than 2/1000. That is 1, 2, a little more than 2/1000 there, right? I didn't measure the wall thickness of the Peterson yet. We'll go do that and see if that can clean up. So you can see the 30 BR die on the Peterson brass, since the Peterson is smaller on the body, so it's not going to force that concentricity like it will on the Lapua brass. This brass wasn't even really, I don't think, even being made when I designed the die. You see here, 2/1000. Check this last one. That's a lot better, right? So we got 1/1000 there. 1/1000 basically. And that is Peterson brass. This has a primer in it too, I'm not sure why. Let's go measure the wall thickness of the Peterson. All right, so this is a Peterson. So we know what the numbers are in the runout, right? 11.1, 11.5, 11.3, 11.8, 11.5. So let's talk about something. That's got 7/10 of thickness variation. Why? Because when that brass got expanded, it didn't all go the same direction. More went one way than the other way. So the lowest spot's 11.1, and if it has 2/1000 runout, it will fully clean up at 9.1. You see, this is the Lapua brass, 11.4, 11.8, 11.5, 11.3, 11.2, right? All Lapua had less than it was 1.5 averagely, right? So it will be at 10 thousandths even, it mathematically won't be all cleaned up, but at 9/8 area it should be all cleaned up. Let's measure this. Peterson 11.1, 11.3, 11.7, 11.9. So the Peterson had more run out, but it's also averagely thicker, or has thicker spots. So we're going to show what the cleanup will do on that. But as you can see, the brass did not come in with all 1,000ths run out or less.